Hi friends, we are going to work out a problem on Kirchoff's voltage law. Let us work out the problem on Kirchoff's voltage law. The question is, find the potential difference between C and D applying Kirchoff's law. So just look at that figure. The figure is already given in that question. Find the potential difference, that means voltage drop across C and D. That means you have to find out the voltage drop at C and D. That means drop across the resistance 8 ohm. That's the question. But what are the data given? E1 value is given 1.5 volt. E2 battery is given, what's the value? 2 volt. And the resistance are connected as shown in the diagram, that value is also given. Now look at the current. The circuit ABCD, just look at that loop. It has only one battery E1. The I1 current is just moving from E1 and passing through 2 ohm resistance, that is BC branch, 2 ohm resistance, and at the C the current doesn't want to take long path, it always likes short path. So the current immediately go through 8 ohm. So the I1 is just going through 8 ohm and reach D. Here the I1 doesn't go to 3 ohm in the D branch because that current is moving towards the negative terminal, but the other voltage, 2 voltage, is a higher potential. So the I1 current is just returned back to 3 ohm, that is in the branch DA. So again I am telling that the current I1 is from positive terminal and go through 2 ohm and CD and DA. In this way it will go. At the same time, from the battery, the loop CDF, from the battery 2 voltage, the current I2 is coming from the positive terminal of the battery and reach 2 ohm in FC branch, and the I2 current at C just going along with I1 because I1 is already passed over to 8 ohm. So the I2 is joined with I1 and passing through 8 ohm and reach D. After D, I1 is going upwards and I2 is going downward 3 ohm and reach the negative terminal of the battery. So the current which is moving towards 8 ohm is I1 plus I2. Is it clear? So from that above square circuit we can have I1, from the below circuit we can have I2. Both currents are passing towards the 8 ohm. D to A is I1 and D to B is I2, mind it. D to A I1 current, D to E is I2 current. Okay. Now let us start to work out. So in any closed network, according to Kirchoff's law, first you have to choose the loop A, B, C, D, A. So I have chosen this loop. So what about that assumed current direction? According to loop, mind it, A, B, now according to the loop what I have chosen, A, B, C, D, A, B. First you mention that assumed current direction, then BC, CD, DA. Clear? So now we can easily find out the algebraic factor of that current and resistance values in that ABCDS loop. Is there any EMF in that circuit? Yes, E1 is equal to 1.5 voltage is there. So just apply Kirchoff's voltage law. In any closed network system, the product of current and resistance is equal to EMF in that circuit. So 2 into I1, R is nothing but 2 ohm, I is nothing but I1. The product of current resistance I1 into 2 ohm. 2 I1 plus 8, the resistance is 8, current value is I1 plus I2. 8 into I1 plus I2 plus 3 into I1, mind it, upward direction, only I1 is good, downward I2. So 2 I1 plus 8 I1 plus I2 plus 3 I1. Why do you put plus sign? Both are in same direction. Listen to B2C, the current original direction black color is not mentioned here, but you have to assume that the B2C is original current direction, the blue orange line is assumed current. Both are in the same direction. So that we have to put plus 2 I1. Similarly, I1 plus I2 current, which is also moving the same direction with that C to D. So that put plus D to A, blue color is going upward. Origin current direction through 3 ohm is the same direction. So put plus. What about in the same direction? You can have 1.5. So here also plus, but not necessary to put plus. So you can have a first equation, just rearrange that equation. That means 2I1 plus 8 into I1 plus 8 into I2, that is 8I1 plus 8I2 plus 3I1, which is equal to 1.5. These are all the same thing. Then how many I1s? 2I1 plus 8I1, that means 10I1 plus 3I1 is there. So 10I1 plus 3I1 is 13I1 plus 8I2 is equal to 1.5. So after simplification, we can have the first equation, 13I1 plus 8I2 is equal to 1.5. Next you have to choose another loop, that is consider EF CDE loop. So EF assumed current according to loop EF FC CD DE. What about the current direction? The arrow mark, black color arrow mark, according to that question. So start with EF. Assumed current and EF current both are in same direction, but here there is no resistance, just leave it. Only battery is there. At the end we can use it. F2C, resistance value is 2 ohm, the current is I2. So I2 into R2, both are in same direction, so plus 2I2. I1 plus I2 current and C to D, blue color arrow mark, assumed current, both are in same direction, so plus I to I1 plus I2. Similarly, D to E, blue arrow mark, refer that D to E, and the current is always also moving downward. Both are in same direction, so put plus. EMF it is also in the same direction, so put plus. So after rearranging that equation, we can have 2I2 plus 8I1 plus 8I2 plus 3I2 is equal to 2. Here 2I2 plus 8I2 plus 3I2, that means 13I2. How many I1? 8I1. So 8I1 plus 13I2 is equal to, what is it, 2? EMF 2. So we can have a second equation. After getting the two equations, we can solve. So before that, you just think about that. It's the very important is getting these two equations, the first equation, second equation. For that, you must know about that the statement of Kirchoff's voltage law. So I have to choose a loop and I have to multiply the current and resistance and put plus or minus, depends on that assumed current, and finally it's end with EMF, whether it is given or not. Depends on that, you can write that equations, very important. Okay, now we are getting the two equations for this problem and we will see how to solve that equations. We can solve those equations by two methods. The first method is Gaussian elimination method. The second one is calculator, using calculator. We will see later. So under elimination method, just write down these two equations from the figure. After applying Kirchoff's voltage law, you can have two equations, isn't it? Next, we have to solve. So in order to eliminate the I1 value, you have to multiply the equation 1 by 8. We have to multiply 13 by the equation 2. So the equation 1 into 8, which gives 104 I1 plus 64 I2 is equal to 12. That is equation number 3. Next, the second equation is multiplied by number 13. After 13 into 8, 104 I1 plus 13 into 13, 169 I2, which is equal to 13 into 2, 26. Hence, we are getting the equations 3 and 4. Now, just subtract 3 minus 4. So, 104 I1 minus 104 I1 cancel. 64 minus 169 I2, that is minus 105 I2. 12 minus 26 is equal to minus 14. From that equation, we can have I2 value. I2 value is 0.133. What is the unit of current? Ampere. So I2 is equal to 0.133 ampere. Next, you have to find out I1 value. So substitute that I2 value in the equation number 1. We get I1 value as 0.033 ampere. So far, we found that the value of I1 and I2. So we just stop it here. How to find out I1 and I2 value from these two equations? By using calculator. We will see now. After getting the two equations, just write down these two equations and just give the values as like this. A1 value is 13, B1 value is 8, C1 value is 1.5, A2 value is 8, B2 value is 13, C2 value is 2. So I have to write these values A1, B1, C1, A2, B2, C2. You have to keep it ready. Then you have to take the calculator, and how to use the calculator in order to get that answer directly, just we will see a video clipping.
Here we are going to see how to solve the two equations using calculator. First of all, we just make mention that whether it is in D mode or not. Yes, now it is in D mode. Now you have to press the mode till you get equation. So for equation, you have to press number 1. Now it will ask unknowns, whether it is 2 or 3. Now we are going to use two variables, current I1 and I2. So that you have to press the button 2. So the A1 value is 13 and press is equal to, it will ask B1. B1 is 8. Then C1 value is 1.5 is equal to, it will ask A2 value, that is the second equation. The first value is 8 is equal to, then it will ask B2. B2 is 13 is equal to, finally it asks C2. C2 is 2 is equal to, it will give the answer X. X is the current value, I1 value. So I1 value is 0.033. Next you press this equal to sign, you can have the Y value. Y value is nothing but I2. I2 is 0.1333. Thus we can get I1 value and I2 value after solving these two equations using calculator.
So quickly you can have the X value and Y value. X value represents the I1 current, Y value represents I2. In this way you can have the I1 value and I2 value using calculator. Now what is the question? You have to find out the potential difference between C and D. Potential difference is nothing but voltage. We know that Ohm's law, V is equal to IR. Here R is 8 ohm. 8 ohm is nothing but connected across CD. So R is 8 ohm. What about that current value which is passing through 8 ohm? I1 plus I2, which is not given in the question. You are going to find out, right? So I is equal to I1 plus I2, R is equal to 8 ohms. Just substitute this value, I1 and I2 value in this equation. You can get the potential difference voltage value is 1.32 volt. In this way we can find out the voltage value, voltage drop at anything in the circuit. We can easily determine using Kirchoff's voltage law. Next we will see applications of Kirchoff's laws. The practical application of Kcl and Kvl is to determine the amount of current flowing through individual electronic component in a circuit and voltage drop in each one. Using that law, we can manipulate voltage and current to the component by controlling resistance to it. For example, in practicals, we can see that the Wheatstone bridge and meter bridge, which are used to determine the resistance of the given material of any materials. Wheatstone bridge, just look up at the diagram. Here you can have a loop ABDA and BCDB. So apply Kirchoff's voltage law for the loop ABDA. You can have one equation, and apply Kirchoff's voltage law for the loop BCDB. You can have another two equations, second equations. So after getting the two equations, we need a solution to solve this, that is Gaussian current Ig is equal to 0. Substitute this in these two equations, we can have P by Q is equal to R by S. So in this way we can get that unknown resistance value. Here we are using Kirchoff's voltage law. Like that, the meter bridge. Meter bridge is a simple form of Wheatstone bridge. So we are applying the same concept here. So from that equation Whitstone's bridge condition, we can have x by r is equal to L by 1 minus L. Thank you.